Hello everyone, I'm Vidya and in this video I'm going to solve a numerical on multiplicative cipher. This video is a continuation of the previous video which was made on the concept of multiplicative cipher, the formula that is used to do encryption and decryption using a multiplicative cipher, and I have also solved one numerical based on encryption using multiplicative cipher. So this video is going to be a continuation of the previous video. Here I'm going to solve the numerical on decryption using multiplicative cipher. So the link of the previous video is given in the description box. I would request you to first visit that video and then come here so that you are in flow with the concept. Okay guys, with this we go ahead with the numerical. The given numerical is to decrypt the cipher text MUKHUR using the key 5. So we'll quickly first revise the encryption and decryption formulas that we have learned in the previous video. Then we'll go ahead with solving this particular question. So if P is the plain text and K is the secret key, the encryption using multiplicative cipher generates the cipher text using formula P into K mod 26, while the decryption of the cipher text in order to recover the plain text is done using the formula C into K inverse mod 26. What is K inverse? K inverse is the modulo multiplicative inverse of K. Therefore, when we want to decrypt a particular cipher text using multiplicative cipher, we are using this formula P is equal to C into K inverse mod 26. So the first step is how to find K inverse. A detailed video on modulo multiplicative inverse of a number has been covered in the previous video. You can check out the link in the description. However, I will also teach it here for this particular numerical. So let us go ahead with solving this numerical. So the first step is to find modulo multiplicative inverse of key. Why do you need this? Because the decryption formula which recovers the plain text is given as C into K inverse mod 26. This is basically nothing but C mod 26 into K inverse mod 26. So the K inverse mod 26 is basically the modulo multiplicative inverse of K. So in order to decrypt the cipher text using multiplicative cipher, the first step is you should be able to find out the modulo multiplicative inverse of the key. What is the key in our case? Key is given as 5. So what do we require? We require 5 inverse mod 26 so that I can compute this and substitute it here. So let us go ahead with finding 5 inverse mod 26. So I'll just brief you quick. So whenever you want A inverse mod n, you should take n into some number x plus 1 divided by a. So n is known from the given question. A is known from the given question. So you'll substitute that. What is x? X, you're going to put different values like 1, 2, 3, 4. You will do this as long as this particular division gives you a integer. The moment you get a integer value, you should not get a fractional value. You should get a integer. The moment you get an integer value, you stop there, and that particular integer is the answer of A inverse mod n. Now note, this is just a quick and shortcut way of solving A inverse mod n. However, the standard algorithm which is used to find modulo multiplicative inverse is called as extended Euclidean algorithm, which I will be covering in detail in my coming videos. But for this numerical, I will use this step and we'll find the modulo multiplicative inverse of 5 and go ahead with decryption process. So with the steps jotted here, let us go ahead and check this out. We are asked 5 inverse mod 26. So what is our n? N is 26 into some number x plus a 1 divided by what is a? 5. So we have to do this division by varying the value of x as a 1, 2, 3 and so on till we get an integer as a final answer. So let us do that and see. The first value of x will try is 1. So 26 into 1 plus 1 divided by 5 comes out to be 27 by 5. That is 5.4, which is a fractional number. So we go ahead with next value of x. So what is the next value of x? 26 into 2 plus 1 divided by 5, which comes out to be 53 divided by 5. That is 10.6. Again, we got a fractional number. So this is not our answer. Then we go ahead with next value of x. That is 3. So we do 26 into 3 plus 1 divided by 5 and check out the answer. We get 79 divided by 5, which is 15.8. Again a fractional number, so not our answer. So we again go with the next value of x, that is 4. So 26 into 4 plus 1 divided by 5, we get the answer as 105 divided by 5, which is 21. As you can see here, you got the answer as a integer, and that integer itself happens to be a answer. So my answer of 5 inverse mod 26 is equal to 21. So we got the answer of 5 inverse mod 26 as 21. So the decryption formula is P is equal to C into K inverse mod 26. And what is the key? Key is 5. So we substitute this as 5 inverse mod 26. So what is 5 inverse mod 26 that we got? We got it as 21. And all the arithmetic is done using mod 26. So now instead of using the formula C into 5 inverse mod 26, we have already found out 5 inverse mod 26, which is 21, and hence we use this formula directly now for decryption. So we won't be using C into 5 inverse mod 26, rather than that we'll be using C into 21 mod 26. So now let us go ahead with the next step. Let us now see the second step. So in the first step we found out a modulo multiplicative inverse of the key. In the second step we create a 3-column table. In the first column we'll note down the ciphertext and its corresponding numbers, which then can be processed by the decryption algorithm. So what is your ciphertext here? It is MUKHUR. Then using the mapping table given below, you have to map each of these ciphertext letters to its corresponding numbers, because the algorithm is processing numbers. So we have to convert the letters into numbers. So for this we use this mapping table of A to Z, which is mapped from number 0 to 25. So it is seen that M is mapped to number 12, U is mapped to 20, K is mapped to 10, H is mapped to number 7, U is mapped to 20, and R is mapped to 17. Now these numbers will be decrypted using the decryption formula. Now what is the decryption formula? Decryption formula is P is equal to C into K inverse mod 26, which as discussed we write it as C into 5 inverse mod 26, and 5 inverse mod 26 is 21 mod 26. So instead of doing P is equal to K inverse mod 26, we would be doing P is equal to C into 21 mod 26. So let us take the first number for decryption, that is 12. So you will do 12 into 21 mod 26. What is 12 into 21? 252 mod 26. Now when you have the number 252 mod 26, since the number 252 is larger than 26, you have to bring 252 within the range of 0 to 25. That is, you have to perform modular arithmetic. Now as I discussed in my previous video also, how do you do this modular arithmetic? A mod B, you get the answer as C. What is C? C is the remainder of A divided by B. Therefore we have to do 252 divided by 26. So 26 into 9 is 234, and the remainder comes out to be 18. So 252 mod 26, the remainder is 18. Hence your plaintext letter is 18. Let us go to the next number. The next number is 20. So you have to do 20 into 21 mod 26. That comes out to be 420 mod 26. So we got 420 mod 26. Since 420 is larger than 26, you have to do modular arithmetic by dividing 420 with 26. So 26 into 16 is 416 and the remainder comes out to be 4. So 420 mod 26 is 4. Coming to the next number for decryption, which is 10. So we multiply 10 with 21 mod 26. The answer is 210 mod 26. Now since 210 is a number which is greater than 26, you have to perform modular arithmetic so that you bring 210 within the range of 0 to 25. So how do you do this mod arithmetic? You take 210 and divide it by 26. So 26 into 8 is 208 and the remainder is 2. So 210 mod 26 is 2 and hence the recovered plaintext number is 2. The next number which you want to decrypt is 7. So 7 into 21 mod 26, we get 147 mod 26. So 127 mod 26. So as you can see, 147 is larger than 26. Therefore, you have to perform mod arithmetic. That is, you have to take 147 divided by 26. So 26 into 5 is 130 and the remainder that you get is 17. Therefore, 147 mod 26 is 17. The next number to decrypt is 20. So you do 20 into 21 mod 26, which comes out to be again 420 mod 26. The answer of 420 mod 26 has already been computed as 4 here. So I write it down from here, that is 4. The next number to be decrypted is 17. So 17 into 21 mod 26 is 17 into 21 is 357 and we have to do mod 26 arithmetic on it. So 357 mod 26 can be performed by dividing 357 by 26. So 26 into 13 is 338 and therefore the remainder of this is 19. So 357 mod 26 is 19. Now I have covered the modular arithmetic and all these computations in detail in my video. I request you to go through that video so you will understand each and every step of modular arithmetic in detail. Rather, you will understand how do I know that 23 into 13 is 358, because I am not doing the multiplication table of what is 26 into 1, what is 26 into 2 and so on and so forth. I am directly using calculator, some method, and I understand that if I do 26 into 13, directly I get 338 and my remainder comes out to be 19. So I've explained these steps, how to do this in the video made on modular arithmetic. Kindly go through it so you'll understand quickly how I directly get 26 into 13 as 338 and then do the subtraction and get a remainder. Because we cannot go on doing multiplication table each and every time and check out, okay, 26 into 13 is 338. So it is too time consuming. So we use calculator for that, but how we use it, that I've explained it in that particular video. So kindly go through that video. So using the decryption algorithm, we have recovered these particular plaintext numbers for the given ciphertext numbers. So ciphertext number was 12, 20, 10, 7, 20 and 17. Our recovered plaintext numbers are 18, 4, 2, 17, 4 and 19. Now we want to recover the plaintext letters and the plaintext word. So for this we require the mapping table which is given below and we find the corresponding letters to each number. So as you can see from the table, 18 corresponds to letter S, 4 corresponds to letter E, 2 corresponds to letter C, 17 corresponds to letter R, 4 corresponds to letter E and 19 corresponds to letter T. So our recovered plain text for the word Mukur with key 5 is the word secret. So we can see that we have successfully recovered the plaintext letter secret by using multiplicative cipher. So a quick revision on the steps for decrypting using multiplicative cipher. The first step is we computed K inverse mod 26. Let us call it as some value A. How did we do this? To do this, you have to take 26 into, go on varying the number X plus 1 divided by K as long as you get integer. The integer is the answer for K inverse mod 26. The second step is we mapped the ciphertext letters to numbers and then processed each of the number by doing decryption using C into A mod 26. So if you get C into A as a number B mod 26, how do you do B mod 26? You divide B with 26 and the remainder R is your answer of B mod 26. Then whatever number you got for R, you again map map it to letters and reconstruct the cipher text word. With this, we come to an end of this video for decrypting using multiplicative cipher. I hope you understood the concept. If you want me to solve more numericals on encryption and decryption using multiplicative cipher, or for that matter any other topic, kindly put it in the comment section. I'll make a video of the same and upload it. So thank you guys. Take care, stay healthy, stay blessed.